Hey students, this is lesson 2.5. We're going to learn how to rewrite and use literal equations and formulas. Okay, go ahead and do this vocab here quick. There's an important definition for you to check out. What is a literal equation? And a good example and non-example of that. All right. There's a couple ways to solve a problem like this. You can just substitute in values and rework the equation. But what I'm going to try and teach you how to do is to transform the equation so it's solving for whatever the variable is that you're looking for. So here we have an equation that gives us the cost if you buy some pizzas and sandwiches. And what we're going to do is transform that equation to get what we want, which in this case is, we want to know how many sandwiches, and sandwiches are y. So the first thing I'm going to do is take this equation, 10x plus 5y equals 80, and transform it using the properties of equality to solve it for y. So I want y all by itself. Now, the way you do this is really the same way as you do equations. Notice that this 10x here is added to the 5y. So if I want to undo that, I'm going to subtract it. So the first step I'm going to do is subtract 10x from both sides. And when you do that over here to this side, it's just an expression. 80 and 10x are not like terms, so you can't like change them to 70x or something like that. You just have to leave the expression. But 10x minus 10x is 0, so that cancels that. And I now have this equation. And then since it's 5 times y, the way I would undo that is use the division property of equality and divide both sides by 5. That would be dividing everything by 5 or multiplying by 1/5 if you want to look at it that way. 5 divided by 5 is just 1y. And then I can separate this into a difference, the common denominator, and just simplify that as much as I can. 80 divided by 5 is 16. 10 divided by 5 is 2x. And now we have a simple equation that will specifically tell us what y is, which is the number of sandwiches, if we know the number of pizzas. So I'm going to substitute in my two values, 3 and 6, to get that answer. So if x equals 3, which is my pizzas, equals 3, then y equals 16 minus 2 times 3, which is 16 minus 6, which is 10. So 3 pizzas, 10 sandwiches, and 6 pizzas minus 2 times 6 is equal to 16 minus 12 is 4. So 6 pizzas and 4 sandwiches. All right. So I'm going to skip this example and just go down, and I'll let you try one here. Okay, change this these two to division property of equality right here. I'd rather use that than divide both sides. And then this one, addition property of equality. And put those in the right spot. The next thing we're going to learn how to do is rewrite a literal equation with only variables. So there are numbers in here. Now, one of the things you can do to help you out here is think of numbers and how you might do it if there were numbers in there, and then apply that strategy, or just use the properties of equality. So I'm going to start with a over x minus b over x equals c. I want to solve it for x, and what that means is I need to somehow represent this equation with x in only one spot, and x and x are the same number, so that's like a common denominator. So I can rewrite this as the difference, a minus b divided by x, is equal to c. Now x is in just one spot, and but I want it to just say x equals something. So I'm going to multiply both sides by x here. And what I was thinking is I don't want x in the denominator because then I'm really talking about a number divided by x, not x itself. So when I do that, this cancels this x and I just get a minus b. And over here I get c times x. And one last step to get x all by itself is just to divide both sides by x. And if I want, I can simplify this into fraction form. And on the left side, and those x's cancel, x divided by x is just 1. And that equals c. One thing I would want to be careful about here, though, is that since I'm dividing by x, x can't be 0. And you don't have to note that, but just think about that. You can't divide by 0, but other than that, it should be good. All right, go ahead and you try that, see how you do. Okay, a lot of formulas are literal equations because I have more than one variable. And sometimes it's convenient just to rewrite those formulas for the variable that we're looking for. Like if you're using, say, the distance formula, and you always are trying to find a rate, well, you might as well just change that into a rate formula, which is what we can do here. So for this problem, we want to know the length of a rectangle with an area of 98 square inches and a base of 14. Well, the area of a rectangle equals length times width. And that looks like that, but we need the length. So I'm just going to change this so it gives me the length. Right now it's giving me the length times the width. And to do that, I just need to divide both sides by w. That cancels those w. And I now get the equation, the area divided by the width is equal to the length, which kind of makes sense. And now I can just substitute my area as 98. My width is 14, base and width are the same. And that's equal to my length, and then just simplify that. 98 divided by 14 is 7. So my length is 7. All right, you try that. Change the formula you need to find the variable you want. All right, again, sometimes it's easier just to rewrite the formula to be a more specific formula for what you want. And in this problem, it deals with Karen walking 3 miles per hour, covering 12 miles. How long did she walk? The formula we're going to want to use here is our distance is equal to our rate times our time. But we want to know how long she walked. And how long is a time? So I just want to divide both sides by r so that I specifically get a time formula. And now all I need to do is take Karen's distance, which is 12, divided by her rate, which is 3, and that's the time, which in this case is, let's see, it's per hour, so that means she has this in 4 hours. All right, you can go ahead and try that on this whale problem. All right, that's it. That leads us to the lesson check. Go ahead and do this, and we'll talk about it next time I see you in class.